So the other factors can be degree of flexibility, how quickly the company can change around and then react, and how quickly they can come out with forecasting, or make sure that the forecasting is accurate or not. And also, companies need to know the consequences of the bad forecast. Consequences of a bad forecast is important to know simply because most of the costly decisions the companies are making needs a good forecast. For instance, based on the forecast, a company can decide to buy, let's say, a $2 million machine. And if the forecast is wrong, that $2 million is waste, right? So that is the whole problem with bad forecasting. So we need to understand also some of the consequences of having a bad forecast. Now, there are different models or methods that we are going to be looking at. We're going to be looking at one is called a simple moving average. We're going to be looking at a weighted moving average and a simple exponential smoothing. We're going to look at exponential smoothing with trend, and then a linear regression, and then just the seasonal model. Okay, we're not going to look at trend as we talked about. Now, based on how do we select these methods? Thus, we select these methods based on the amount of historical data that is available to us. If the historical data is 6 to 12 months, weekly data are often used. This is a stationary. That means it does not have any seasonal effects or trend effects or anything like that. It's a short forecast horizon. It's not very accurate at all. So it is sort of like a rough figure kind of a thing. So that's what simple moving average is. The next one is if we have some kind of observations, again, for stationary, that means no trend or seasonality, and then maybe a little better than simple moving average kind of an accuracy, then you can choose the weighted or the simple exponential smoothing. The exponential smoothing with trend is used one with trend basically. So this is a stationary thing, but then we are going to use trend. And we're going to also use it for a short forecast horizon, maybe 2 to 3 months, maybe less than 6 months. That's what we're talking about. Linear regression is another method, and we're going to be using linear regression in the seasonal model. Okay, so linear regression and seasonal model, you need to have certain observations. If you have some observations per season and you have certain observations over a period of time, then we can use the seasonality part of it. And actually, it is much better. It is short to medium kind of a range that we're talking about. Short to medium is basically you're looking at about 3 months to 2 years kind of a thing. Okay, and within 2 years kind of a thing is a forecast horizon, and this is actually much more accurate than the others. Okay, so this is probably the most accurate that we can get over the others. So we're going to be looking at these kind of methods. So we're going to be looking at 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 different models when we go to the analytical part of it. Now, before we go to the analytical part of it, let's look at certain things. One of the things that we want to look at is the forecast errors. So you said that some time back we just said that, hey, if you do a bad forecast, it is going to be detrimental to the company in the sense that you're going to have a costly decision based on this bad decision, the bad forecast, and then you're going to lose some money, right? So we don't want that. We want to look at errors as well. We want to make sure that we do not have that much errors. Okay, so the forecast error is the difference between the forecast value and what actually occurred. Let's say you predicted you're going to sell 40 TVs next month. The next month come. At the end of the month, you have sold only 30 TVs. Okay, the forecast error is 40 TVs minus 30 TVs, which is 10. So you forecasted 40, but actually what happened was only 30. So the error is 10, right? So we're going to look at these kind of errors, and then we're going to look at how we can look at it from various percentages, deviations, and tracking it and all that stuff in a few minutes. The sources of error are two. One is a bias. A bias is when a consistent mistake is made. So whenever we have a mistake that is consistent over a period of time, we call it a bias error. Random error is you do not know how it happened. It is inexplainable. We don't know, and that is a random error. The measurements of errors are three. One is called the mean absolute deviation. Another one is the mean absolute percent error. And then the third one is a tracking signal. So we're going to be looking at these kind of measures of error as well. So let's look at the equations of this. Ideally, MAD, the mean absolute deviation will be 0. That means ideally you'd want no forecasting error. Larger values of the mean absolute deviation indicates a less accurate model. So if you have more and more deviations from as errors, then we have less and less type of accuracy in your model. Okay. Now, MAPE, which stands for mean absolute percent error, is basically the MAD, which is the mean absolute deviation over the average demand. Tracking signal, which is TS, is basically the running sum of forecast errors over the mean absolute deviation, which is MAD. Okay, so these are some of the things that we are going to be calculating in the next video. Okay, we'll see you soon.